Hi there, welcome to today's physics class. For today's class, we're discussing about momentum and impulse. By this concept here, we're looking at momentum and impulse. For this topic here, or for this concept here, there are two key terms here. The first one is called momentum, and the second one is called impulse. So for today's physics class, we're discussing about the concept behind momentum and impulse. But for now, let's start with the concept of momentum. Let's start with momentum. Let's start with momentum. By definition, what is momentum? Let's say I have a mass of a body. Let's say I have a mass of a body, and the mass moves with a specific velocity. The momentum of that body is simply the product of the mass of the body and the velocity with which the body moves. So I'm saying that momentum can be defined as the product of mass of a body and the velocity with which the body moves. So I'm saying that momentum is simply the product of the mass of a moving body and the velocity with which the body moves. That's momentum by definition. Momentum is represented by using small p. So momentum is what is abbreviated by using what there, a small p. All right. You'll be asking that why is momentum not m? We know that m represents mass already, so we can't use m for momentum. So rather we use what, p for momentum. So we're saying that momentum p mathematically we're saying that momentum which is p is equal to the product of mass of a moving body and the velocity with which the body moves. So from here now, we're saying that p, momentum p, is equal to the product of mass, that's m, times velocity. Let me call my velocity here. Let me call it u. Velocity can be represented in two phases. Either I use v or I use u. This one here is a type of velocity. This one here is what? Is a type of velocity. This is called final velocity. This is called what, the initial velocity. So let me just use u, right? You can use v if you want to, but let me use u here. So we're saying that momentum p is equal to what? Mass times velocity of the moving body. If this is true, we are saying that from here now, we are saying that for mass, let's get the SI unit for momentum, please. SI unit for momentum. Momentum p is equal to mass. What we know generally is that mass is measured in what? In kilogram. So I have kilogram times velocity. Velocity is what? In meter per second. Let's get the SI unit. Therefore, the SI unit for momentum is equal to what? Kilogram times mass is kilogram mass over second. So this is called kilogram meter per second. So the SI unit for momentum is simply kilogram meter per second. That's like the SI unit for momentum. All right. At this point here, I haven't got the SI unit. I can express the SI unit as saying kilogram meter s to power minus 1. This is still mathematically correct. That's kilogram meter per second. You see the same thing as this one here. So I have this one here as my SI unit for momentum. All right, with this idea here, let's take some example to further explain the concept behind momentum. So I'm saying that let's example one. Let's say I have a mass of a moving body. Let's say I have a mass of a moving body to be equal to 15 kilogram. Next up, the mass of that body moves with a velocity moves with the velocity of, let's say, 100 meter per second. The question says find the momentum, find the what? Momentum. Find P. Find the momentum P of the body. So of the moving body per se. So in this case here, let's get momentum. Solution here. Our first task says that I'm given mass and velocity. Find momentum. It's very simple. Recall I said that momentum P is equal to what? Mass times velocity. From here now, I said you can choose to use U or V. You see the same thing, please. All right, at this point, the momentum P is equal to what's mass? 15 kilogram. 15 kilogram times velocity is what there? 100 meter per second. From here now, momentum P is equal to 1500 what there? Kilogram meter per second as my SI unit for what's it called? Momentum. So it's like the concept behind momentum. Let's take one more example to further explain the concept behind momentum. All right, example 2. Example 2. Let's say I have a mass of a body to be equal to 154, let me say 15,400 gram, and I have the velocity of the moving body to be equal to 15 meter per second. Find momentum. P is unknown. So how do you get momentum here? The same task here. The concept here is quite simple, right? What we know very well that momentum P is equal to mass times velocity. But observe that my mass is always in what? In kilogram, not in gram. So my task here is to convert this gram to what? Kilogram. So divide this one here by 1000. So I will have 15.4 kilogram as my converted value, right? So I'm saying that 15,400 gram is equivalent to 15.4 kilogram. Simply divide by 1000, you have this one here. So it's not easy for me to find what? My momentum P. So P now is equal to mass. That's what? 15.4 times velocity is what? 15, yeah? Multiply 15.4 by 15.4 by 15, 15.4 by 15 there, I have 231 momentum. Z is what? Kilogram meter per second. Kilogram meter per second as my SI unit for momentum. So these are how to calculate for momentum of a given body. All right, let's dive into the second concept called impulse. So let's talk about impulse and let's try to solve several examples on impulse. After that, we just take some past questions, some jam WAEC past questions on momentum and impulse and solve together. Let's discuss impulse. Let's discuss impulse. Let's discuss impulse. By definition, impulse is simply the product of the average force of an object or a particle and the time interval it takes the force to act. I'm saying that impulse is simply the product of the average force of an object or particle and the time interval it takes the force to act. That's like the definition for impulse. It's represented by J. Represented by J. So note that impulse is represented by J, momentum by P. So note that impulse is abbreviated with J. Some people use I, but we know that I represents inertia. So to avoid confusion, we can use J. or you can still use I if you want to, but for me, I'm using J, yeah? So now we're saying that impulse is simply the product of the average force of an object or particle and the time interval it takes the object to act, or the force to act per se. All right, at this point here, mathematically, I'm saying that moment impulse, please, impulse. I'm saying that impulse, which is J, is equal to the product of what? Force and what? Time. So I'm saying that here, moment impulse J is equal to what there? Force times time. Let's get SI unit for impulse. So note that impulse J is equal to what? Force. We know that force is measured in what? In Newton. Times time is in seconds. So therefore, the SI unit for impulse is equal to what? Newton second. So this is my SI unit for impulse. So the SI unit for momentum is simply kilogram meter per second. The SI unit for impulse is what? Newton second. All right, with this idea here, at this point here, I want you to know something, please. Very important. Note that momentum and impulse are similar in the sense that they have the same SI unit technically. We are saying that momentum P is what? Kilogram meter per second. We are saying that impulse J is what? Newton second. And I'm telling you that they have the same SI unit technically. Let's prove that. From here now, let's prove that, please. We said that momentum P is what? Mass times velocity. And we said it's measured in what? In kilogram meter per second, which is true. We now said impulse J is what there? Force times time, which is what? Newton second. Pick out this one here. We said impulse J is what? Newton second. True or false? True. But I'm saying Newton here. Newton here represents force. So we said force now is equal to mass times acceleration from Newton's second law of motion. So force, Newton here represents force. And we know that force is what? Mass times acceleration. Now it means that force, which is what? Mass is what? Kilogram. We know that mass is measured in what? In kilogram times acceleration in what? In meter per second squared. From here now, we are saying that force can be expressed as kilogram meter per second squared. So from here now, I'm saying that 1 Newton represents 1 kilogram meter per second squared. So I'm saying that 1 Newton, this Newton here, which is force, represents what there? 1 kilogram meter per second squared. If this is true, I'm saying that impulse J is equal to Newton second. We established that Newton is equal to what? 1 kilogram meter per second squared multiplied by these seconds here. Seconds, cancel out seconds, left with 1 second here. So impulse, which is equal to kilogram meter per second. So observe that the SI unit for impulse is not the same as the SI unit for momentum, as you can see. So impulse and momentum have the same SI unit, right? Technically, as I have proved to you now. Now, the concept says that is momentum and impulse the same thing, or is there a similarity between momentum and impulse? Note that there's a difference between momentum and impulse. What's the difference? Note that we said we said that momentum P is equal to what? mass times velocity. True or false? True. Now, at this point here, note that impulse J is equal to what? The change in momentum. That's like the difference. Note that momentum P is equal to what? Mass times velocity. That's true. We know that. Note that impulse J is equal to what? Change in momentum. So the increase or decrease in momentum is called what there? Is called what there? Impulse. So impulse is simply the increase or decrease in momentum. That's like the difference between them. So impulse, this is impulse. So I'm saying that impulse here is simply the impulse J is simply the increase or decrease in momentum of a body. In momentum of a body. So I'm saying that the difference between impulse and momentum is that momentum P is equal to mass and velocity. Impulse J is equal to the change in momentum. When I say change in momentum, what do I mean? I mean mv minus mu. Very important. This is V is initial, final. Momentum is mass and velocity. Mass and velocity. So start with the final velocity first before initial. So this is like the expression for change in momentum. This is here. So note that momentum is simply the increase or decrease in note that impulse per se is simply the increase or decrease in momentum. So that's what you need to note at this point here. All right, let's use the idea of impulse to solve several examples. Welcome back. Let's use this idea of impulse to solve some example. Example 1. Example 1. Let's say I have a force of an object to be equal to 40 Newton, and the object, it takes the object to move with a, let me say, time to be, let's say, 100 seconds, right? So the time that interval it takes the force to act is 10 seconds. The question says find the what there, the impulse, that's J. From here now, solution, what we know is that J impulse is equal to what? Force times time. What's force here? 40 Newton times what's my time here? 100 seconds. Multiply this. Impulse J is equal to 4,000. What's my SI units? That's what the 4,000 Newton second as my SI unit for impulse. That's Newton second, as you can see. So this is how to solve problem under momentum and impulse. Let's take some WAEC questions and let's solve them together and let's see what we can do. All right, let's take this WAEC past question and let's solve together. One says a body of mass 5 kg moving with a speed of 30 meters per second is suddenly hit by another body moving in the same direction, thereby changing the speed of the former body to 60 meters per second. What is the impulse received by the first body? At this point here, your first task in science is to list out the given parametric unit. What are you given? First there, I'm given a mass, that's M, which is what the 5 kg moves with the speed of 30 meters per second. So when I read the question, I was having two velocity. One is 30, one is 60. Call this one initial velocity and call this one the final velocity. So I'm having initial velocity, that's u, to be equal to what? 30 meter per second. Also, I'm having final velocity, that's v, to be equal to what? 60 meter per second. All right. So that's what I'm given. So of course, we find the what? Momentum, Abby. Yeah. Find momentum, or perhaps impulse, please. Impulse. Impulse J is unknown. Let's get impulse. This is somehow tricky. Observe that I'm given mass, initial velocity, and final velocity. Find impulse. What we know is that impulse J is equal to force times time. From this question here, I'm not given force. I'm not even given time. So how will I get impulse with these two formula here, with this one here? So in this case here, I can't use this one. Observe when I said the difference. Observe that I said that the difference between momentum and impulse is that impulse, recall that I said impulse J is equal to what? Change in momentum. True or false? True. So I'm saying that impulse J is equal to change in momentum. When I express change in momentum, I said J is equal to mv minus mu. True or false? True. So the expression of change in momentum is what? Mv minus mu. So from here now, I'm seeing m and m are the same thing. Factorize it out. J here is equal to m into v minus u. M times v, mv, minus minus, m times u, mu. So at this point here, so from here now, J, that's impulse, J is equal to mass. What's mass here? 5 is equal to 5 into v. What's v? That's 60 minus 30 as my u is 30. So that's all. Let's get J, please. J, which is impulse, is equal to 5 into 30. From now, J now is equal to 150 Newton second, please, as my answer to this WAEC question here. So this becomes my answer to this question here. Let's take example 2 to further explain momentum and impulse concept. Example 2. A constant force, 5 Newton, acts for 5 seconds on a mass of 5 kilogram, 5 kilogram initially at rest. Calculate the final momentum. Let's get this done. So to that question there, example 2, my given solution to that question, what am I given? I'm given that a constant force, I'm given force, that's F, to equal to what? 50 Newton, sorry, 5 Newton per se, 5 Newton, acts for 5 seconds, so that's time, that's small t, 5 seconds, on a mass, I'm giving the mass, that's M, to be equal to what there? 5 kilogram. Observe that you are hearing that initially at rest, sorry. So when a body is initially at rest, it means that its initial velocity is equal to 0. That is, u is equal to 0. Very, very important. When we discussed the concept of motion in our last class, in our last video, we spoke about motion. I established that when a body starts from rest, its initial velocity u is equal to 0. When a body finally comes to rest, its final velocity v is equal to 0. So I stressed this point during that class of motion. So I'll drop the class to motion in the description of this video, right? So yeah, we're saying that initially at rest, so it means that u is equal to 0. Calculate the what? Momentum. So momentum is unknown. Momentum, which is p, is unknown. Let's get it done. How do you solve this? My first task says observe something place. What we know is that momentum p is equal to mass times velocity. True or false? True. So for me to find momentum, I need two things: mass and velocity. Observe, I'm given mass, so I'm not given what the velocity. My task now is what? Get velocity. So how do I get velocity from this parameter here? Recall something. Recall that force. Recall that force is equal to mass times acceleration. True or false? True. For me now, I need to know acceleration for me to get velocity. So from here now, let's make acceleration subject. This becomes force is equal to ma. I want to make acceleration subject here, so divide by m. So from here now, acceleration a is equal to force over mass. Make acceleration subject here. This is what I'll be having here. So acceleration a is equal to what's force? Force is 5 all over what's my mass? That's 5. So acceleration becomes 1 meter per second square as my value for acceleration. All right, at this point here, I'm looking for what? The velocity. Don't forget that we're looking for two things. The first one is mass and velocity. I know my mass, I don't know velocity, so let's get velocity here. At this point here, acceleration is equal to 1 meter per second squared. So we said to find momentum p, we said we need two things: mass and what? Velocity. I know my mass, no problem. My task is to get velocity. But from here now, we said that from our physics, from the beginning of physics, we said that acceleration, which is a, is equal to what? The change in velocity over time. We said this. So I'm saying that acceleration a is equal to v over t. I'm looking for v, so make v subject. So v is equal to at, acceleration times time. Let's get v. Therefore v is equal to, acceleration is 1 multiply time is what? 5. So it means that my velocity v is equal to 5 meter per second. So let's get momentum. Momentum now, therefore momentum, which is p, is equal to mass times velocity. What's my mass? Mass is 5 times velocity is what? 5. So my value here for my momentum p is equal to 25 kilogram meter per second as my answer after finding the momentum of this question here, as you can see in front of you. All right, let's take one more example and end this concept of momentum and impulse. Welcome back. One final example. Example 3. When taking a penalty kick, a footballer apply a force of 30 Newton. So solution, I'm giving force, that's F, 30 Newton for a period of 0.5 seconds. That's time, that's t, 5 seconds, sorry, 0.05 seconds. If the mass of the ball is 0.07, then I'm giving mass mass, that's m, to be equal to 0.075 kilogram, calculate the speed with which the ball moves off. So the speed there, we said speed and velocity are the same thing, that because they have the same SI unit. So I'm looking for what the velocity here, which is speed. Speed, that's my v, is unknown. How do you get velocity from this question here? Alright, velocity, that's v, right? So from here now, what I know very well is that velocity is in two cases, right? We know that acceleration is equal to what? Velocity over time, right? So I know time is there. I don't know, I'm looking for this one. I don't know acceleration, so let's get acceleration first. After getting acceleration, then we can find velocity. But recall that from here, recall that to get acceleration, we know that force F is equal to mass times acceleration, true or false, from Newton's second law of motion. From here now, force is equal to what's mass? Mass is 0.075 times acceleration is what there? Acceleration is unknown, A. So what's force? Force is given as 30. From here now, if I multiply through, I'll have that 30 is equal to 0.075 A. Let's get A here. Divide here by 0.075. Divide here by 0.075. My acceleration A now is equal to this here. Cancel this here. Acceleration now A is equal to 30 divided by 0.5. I'll have 400 meters per second squared as my acceleration. So now because the task is nice simple, I'm looking for velocity v, which is this here. I need to know two things: acceleration and time. So from here now, I'm giving acceleration to I know acceleration is 400. What's my time? Time is 0.05. So let's get velocity. So recall that acceleration A is equal to what? Velocity over time. Make velocity subject, v is equal to at. V is equal to what's A? 400 times what's t? Time. That's 0.05. Multiply 400 by 0.5. I'll have 20 meters per second as my answer after finding the velocity of this question here. So if you found this class helpful, do well to like, leave a comment and share, and also share to your friends and classmates so they can learn too. See you in our next class.